Okay, next we're going to look at the valve module itself. So what we're going to do, we're going to pop it off its mounting to the check stop strainer and set that aside. And we'll look at this module now. You can leave these appendages, the end plug and the flow control, on there. I'm going to take it apart so that we can look at the inside and get a look at the internals of this thing. You need to be careful when disassembling this. These little nuts that hold the bolts will get lost very easily. When you remove the top assembly, this gray part with the black cap on it, you want to remove it as a complete assembly. This exposes the water chamber of the valve. The water chamber has its water diaphragm in it. It has a metal orifice plate with a rubber seat in the middle. And it has this tiny spring. They disappear when they hit the floor, so you don't want to drop them. That leaves us with the control module itself. Now you'll notice there's a stainless steel separator cup in this module that keeps all the water in the lower part of the valve. You should never have water in the upper part called the control module. Sometimes if you do, you'll see little bubbles of water going through here. If that's the case, it has to be taken apart, all that moisture removed and dried and reassembled. Now the top operator, if we put our little spring back in, and we'll put our orifice plate back in, because these are the working parts of the valve. And if you take this valve and you operate the push button, you will see that plate is pulled down and it's held down by a magnet in the top part. And it will be held down as long as that magnet has a force on that metal plate. This is your timing function. The vacuum inside here is pulling that magnet upwards toward that plate, and the plate moves down away from the water diaphragm. The water diaphragm itself operates pretty much like a flush valve. If you look at the bottom side, you can see there's a small bypass hole in this molded circle. That's like the bypass on a flush valve diaphragm. What happens is, when you lift the plate off the little seat in the middle of that diaphragm, it allows line pressure that has built on top of the diaphragm to escape through that hole. And that in turn allows incoming water pressure to raise this diaphragm off its seat. The valve seat, as you can see, is here, and it exits to this port here. So this is your water flow, comes in here, it comes up through the seat and into the exit port. And it's all done by the pressure of the incoming water. When this port is blocked by the metal plate, it allows the pressure to build on top of this diaphragm and push it down. And because you've got more area on the top of this plate than on the bottom of the plate, bottom of the diaphragm, this is your area on the bottom of the diaphragm, so you can see this area on the top side that is pressurized is quite a bit larger. So of course, more pressure, larger area, you're going to hold a lot more pressure from coming in. That's how the valve closes. As long as this plate is covering that small hole, the valve is closed. If it's lifted off, the valve opens. That's pretty basically how the water chamber works. The little spring that we find that goes on top of this between this part and the valve operator helps this plate push down and close. It's a very, very weak spring, but it's enough to shut off the water flow. So now we're going to look at the operator itself. Oh, on this plate, if you hold it edgewise, look very closely, you can see that one side of this rubber seat is a little larger than the other side. It's always best to have that larger side facing down to close off the flow to this hole. You have a much better chance of it sealing that way. Let's put it back in the operator here. I don't know, we can get into this operator, but I don't recommend it be taken apart. There's rarely any problem with this operator, and if it's taken apart, there are a number of pieces in there that you have to be careful with because they have to go in the proper sequence and they have to be in their proper location. Let's see if I can get that off of there without getting things all over the place here. Okay. Of course, the plate and the spring will fall out once they have no attraction from the magnet. It's a circular magnet. It's usually it's got to be very consistent in its magnetic strength or magnetic field. We do have specifications of what it has to be, and the spring, of course, is also very, very critical in moving the magnet away from the plate. On top of the magnet and its magnet retaining plate, we have the upper air diaphragm and a small spring. Now the way this top part works, let me get it assembled here. Well, I think I'll keep it apart for now. What happens when you release your push button and draw a vacuum through the tubing, that vacuum connects underneath the bottom of this magnet, or this diaphragm, creates a vacuum. As that happens, this is pulled down, and it in turn allows the magnet, which is underneath it, to move down. And this assembly will move up and down in the air operator. And its sole purpose is to lift the little orifice plate off its seat. Now, as long as you have vacuum applied to the bottom side of this diaphragm, it's going to be sucked down, pulling the magnet down, allowing the valve to run. Purpose of the timing adjustment, which is in this body here, is just a small needle valve, and it relieves that vacuum over a period of time, which determines the length of your flow cycle. Now, the other thing you need to know about this air diaphragm is that when you put a vacuum on the bottom of it, this spring pushes it down against the top of this plate, and it seals a small hole in the middle. So that helps retain the vacuum that you built until it's relieved through the timing adjustment. Of course, this spring will hold that down until such a time as there's not enough vacuum. It will allow the bottom spring to raise the magnet away from the orifice plate and let it drop onto its seat. And that is pretty much the way the top part operates. There is one more thing that I do want to mention in regard to this. As soon as I get this assembled, if you look around the corner from your air connection on the pneumatic operator, you'll see there's a little port here. This port must be vented to atmosphere. When you push your button, you can feel and hear a small puff of air coming through there. That evacuates the air from the diaphragm. And of course, when you release the button, you're pulling vacuum, and it will pull that diaphragm down and seal it like a check valve. So it will hold that vacuum in there until it's relieved through the timing port. Okay, that pretty well covers the operation of the top part and the bottom part, really. It sounds complicated when you first hear it, but once you understand its operation, it becomes pretty easy to troubleshoot the valve and find out where problems are occurring, if there are problems. My experience with these valves has been that if they're properly installed, properly sealed, and maintained, they last a good long time.